Saxon Algebra 1, lesson 119. Look, I have one more box left to tick for the year. We'll talk about that tomorrow. Lesson 119 is a very exciting, formative lesson in your algebra education. It is directly related to the last lesson we did, completing the square. Let me remind you that we know these things called quadratic. That's a quadratic expression. If you do this, it becomes a quadratic equation. So expression, equation, it's just a question of whether there's zeros there. They're really, really close to the same thing. This is called the standard form of a quadratic equation. This one would be, because it has the equal sign. And what we have learned and been talking about is there are three ways to solve. The first one we've been doing for quite a while. That is called by inspection. And that sounds weird, but we're looking for a pair of numbers that multiply to this and add to this, and we write them as a pair of binomials, and then if we need to, we can solve from there, right? We look at it and we follow those little rules that help us figure out what the right numbers are. Inspection means to look at something, right? So that's what we're doing. We're just looking at it and figuring it out. And there's also what we have been working on lately, advanced inspection, which is where we have a coefficient other than 1 here. And the trick to that is we have to multiply A times C. Then we find two numbers that multiply to that product and add to the coefficient of B. So that's advanced inspection. We learned that as something separate, but it's really two flavors of the same ice cream, if you will. The thing that we learned last time is to factor by completing the square. And what we learned that means is it's a long step. It was lesson 118 or 117. It's 118. It's a long series of steps that we do to create a perfect square using a magic number, and then we simplify to get our answer in the end. Now, there's some advantages to that. Solving by inspection only works sometimes. John has been careful to give us nice, cute quadratic equations that will simplify just by looking at them. But sometimes this doesn't work. The nice thing about completing the square, and also the third one, and I'm going to write this down in a minute, is that they work all the time. No matter what your original quadratic equation is, you will always be able to solve it. So if it's integers, if it's fractions, if it's radicals, next year we'll learn we can even have imaginary numbers, but we can still solve them by completing the square. And that's a really good thing about completing the square. The bad thing about completing the square that mathematicians have recognized for hundreds of years, once they got this completing the square thing sorted out, they came to the conclusion that is a pain. That is a lot of steps, and it's a lot of fussing around, and we don't like it. That's one thing I love about math. Sometimes the world thinks that mathematicians are like fussy nerds that love these long, intricate processes. Okay, maybe partly true, but mathematicians are always looking for the easier way to get something done. There is no like inherent love of things to be complicated just to be complicated. So and by the way, you're a mathematician too, so you're part of this club. we're looking for easier ways to do it. And that's how they came up with this idea that we're exploring today, which is to solve it using a formula. And we call that formula the quadratic formula. Okay, so what they did was they took this process of completing the square and they kind of skipped the steps so that you can go from the beginning to the end of completing the square by using a formula. Excuse me. I'm so excited I'm losing my voice. It's a really cool idea. Let's take the drama out of this. Let's figure out a formula that we can just plug into that gets us the end result we want with a minimum of fuss and bother. I think that's beautiful. And so they developed this quadratic formula. I'm going to show it to you, and then I'm going to show you how they came up with it. Copy that down. We're going to memorize the heck out of this. And P.S., I will be testing you on this for the final exam. And so you might as well memorize it right now. The formula is x equals minus b plus or minus the square root of b squared minus 4ac. And then the whole thing is over 2a. Sometimes students accidentally make the assumption that only the square root part is over the fraction line. No, it's the whole thing is a giant fraction. So you'll notice that the x and the b and the a and the c, those all come from this. Okay, and I'm going to show you exactly how that works. But I want you to understand that what we're doing is saying if you want to solve this thing for x, this formula will get you right where you want to be. Now, how did anyone ever come up with this formula? That is what I'm going to show you next. It's lovely and magical. But first, I want to write here, number 1 works sometimes, depending on the numbers in your quadratic equation. This may or may not work. These two work all the time. I'm just going to put the numbers by them so that it's clear. This is 2 and 3. Both of these work all the time. No matter what numbers you have up here, these will always work, okay? So one of the points John tries to make, but I would argue against him, is that from now on, in Algebra 2, because really this year is over, we're going to lean more toward these, which is true, but I will also say it's always a good idea just to glance at a quadratic and say, is there any chance I can factor this by inspection? Because at this point, you're probably pretty fast at it, and you can glance in just a few minutes, not even a few minutes, a few seconds, 15 seconds, you can just run the possibilities by and see if, is there any way I could do this by inspection? It's usually worth taking the time. Unless John says something like solve by the quadratic formula or solve by completing the square, then you have to do it his way. But if you just stumble across a quadratic, it's always worth just taking a look at it and seeing if it works by inspection. Okay, so we will continue to use all 3 of these factoring strategies. All right, how the heck did they come up with this? How do they know that this will give you the answer to x in an equation like that? Well, what I'm going to do is I'm going to complete the square using just the letters. I think John may ask you to do this in your homework. Okay, learning how to do this may seem really weird and arcane, but it's nothing more than just completing the square. So we'll practice doing that. Okay, so we start with the standard form of a quadratic equation, right? This is just what I had at the top of the other page too. Now we're going to start completing the square. Now we haven't done completing the square when there's an a coefficient, because it's always just been 1. But the first thing we have to do is divide away the a term, all right? So this is our step 1. We just want to turn this a into a 1. We don't want a number here. So these are my words. Divide by a to set the first coefficient to 1. This cancels. Now we have a 1 there. That's exactly what we want, okay? This also cancels. So what we have is x squared plus, and I'm going to write this as a separate fraction, which is just a style issue, but it's going to help us in a few minutes when we get ready to do that magic number. All right? So x squared is by itself. 0 divided by a, that's nothing. So we have a's here left behind. Okay, now I need my magic number, don't I? So what I do is I take our value for b, which is b over a. Now normally we say it's b divided by 2, right? But I want you to notice that that equals b times 1/2. We haven't gotten to this yet. But if your b coefficient is a fraction, it helps to write it this way because it's easier to do the multiplication. If I just try to divide this by 2, I'm going to cry because I've made a complex fraction. So I'm going to multiply this by 1/2, and then I'm going to square it. I draw the arrow to this because I'm going to want that later. This squared equals, it's going to be b over 2a, right? That's just me multiplying what's inside of here to make one fraction. And then when I square it, it's b squared over 4a squared. That is my magic number. Oh, Lord have mercy. Oh, I forgot to kick this to the curb. I'll do that next. Okay, so here we have x squared plus b over ax. Kicking it to the curb equals minus c over a, okay? 2. Kick c to the curb. Those words will come back later, okay? 4, 3, I have to say 3. Calculate the magic number. I did that up here, so that's why I'm going out of sequence. 4, add magic number to both sides. Sorry if my steps are written too small. I'm trying to squeeze them in. Okay, so there's my magic number, and I have to add it to both sides. So it's going to be x squared plus ba over x. Now you can see why I wanted to write it like this instead of that, because I knew that this part I was going to need for my magic number calculation, and it's easier to visually just pull that if it's written separately. Okay, bax plus b squared over 4a squared equals, and I'm going to have to squish this just a little, minus c over a minus plus b squared over 4a squared. Wow, that's a mess, isn't it? Okay, hang on a second. Let me pull and flip. Okay, so now we're at the top of the next page. So this is my original expression. I divided away the a's, and then I calculated and added the magic number to both sides. Let me recopy. X squared plus b over ax plus b squared over 4a squared equals minus c, whoops, I said c, but I wrote a, plus b squared over 4a squared. These are my magic numbers. They match. I left myself a little room here because I can see I'm going to have to add these together, and I know I'm going to have to adjust this fraction. So that's why I put a little space in here. Our fifth step, I'm going to change to the other side now, is to write as a perfect square. And I'm going to say write the left side as a perfect square. Beautiful. I don't need this page anymore. I copied that over. Okay, how do I write this? Well, I know it's going to be binomials like that. I know it's going to be x here, but what goes here? Oh yeah, that's where I drew that arrow, right? Here it is unmultiplied, here it is multiplied. That, the inside parentheses in my magic number calculation, is what goes here. So b over 2a. Boy, that looks complicated, but let's check it and see if it works. If I multiply these together, I get b squared, check, 4a squared, check. The multiplying works. If I add them, b over 2a plus b over 2a, okay, the bottoms match, so I just add the tops. I get 2b over 2a, and I can simplify out the 2's, and that works too. Okay, good. That means everything is working. That means I can rewrite this as x plus b over 2a squared, right? I can use my collapsing pink cup and make it come down to this. Beautiful. That looks really good. And it's also part of 5, but I'll make it a separate step. Simplify on the right. Because we've got these two fractions we need to add together. Now, we need to make the denominators match. This is an a, this is 4a squared, so I better multiply this by 4a, right? That's a c. I just accidentally wrote an a, remember? Let me make that just a little clearer. Okay, so now when I multiply those together, this becomes minus 4ac, right? I'm just rearranging the order of the letters. So this is like this. When I add them, I'm going to write the denominators match, so I can add these in any order I want. I'm going to put the b squared first because it's positive, and I'm going to put the minus 4ac, which I got here. I'm going to put that after, that way the minus sign is protected, and I like that. And the whole thing is over 4a squared. All right, that's my denominator. All right, things are coming along really nicely. We are almost there. Now we see, okay, this exponent, we don't want that anymore. So for 7, we take the square root. And we're allowed to do that. We can just take the square root of both sides. And then these two cancel out. So we have x plus b over 2a equals, now we have to do plus or minus, right? Because that's what we do when we take a square root. And I also noticed that this is going to simplify. I mentioned that to you yesterday, that the bottom of the fraction on the right will always be a perfect square, and it will always simplify. So I'm going to leave the square root just on the top. It's b squared minus 4ac over, I don't need a pig house on the bottom anymore because the square root of this is 2a. Okay, so that's out of the pig house now. It's running wild. Now it's a free wild pig that's truffle hunting in the forest, and I'm happy for it. Last step, we just use algebra to solve for x. So we want this x by itself, just like we did yesterday. So we're going to subtract the b over 2a, subtract the b over 2a. On this side now we just have x equals Now, look at this. I'm going to write it twice. Minus b over 2a plus or minus there's what we've got. Now, remember yesterday I told you that we preferred to have these two fractions separately, that it would become mandatory later. Now it's a little bit more like a style preference, but later it's going to be important that we write these as separate fractions. And so I told you just get in the habit of doing that right now. Well, I am contradicting myself and I'm creating a footnote. For the quadratic formula, we don't follow that rule. We put these two together. Minus b, I'm copying this, right? Because the denominators match, I'm creating this as a single numerator, and then the denominator is here, and look what we have done. We have successfully recreated the quadratic formula that I gave you way back here in the very beginning, right? It's this. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Yay! So we are able to derive, is the word we use. We're able to recreate the quadratic formula by taking the standard form and completing that with the square, just using the letters instead of numbers. This is what we get. So the good news is we now get to skip. Look at this whole process, right? I know I write big, but 2 pages, come on, right? 8 steps, and I could have written more if I wanted, right? I could have spaced them out a little bit more. But this is where the mathematicians of old, this was in the mid, like 1400, 1500, 1600s, I think is where they were shaking this out. And different mathematicians solved it in different places. Now we can go from beginning to end without all of that nonsense. That's what we're going to practice doing now. John will give us a standard form of a quadratic equation, and we will use the quadratic formula to calculate the answer without all of this. Okay, let's do it. There are 3 of these. Example 119.1. There are far fewer steps in this process now that we are going to use the formula, but don't let me pretend that this is just a walk in the park. It's still a bit rigorous. 3x squared. The sun is shining on my book so severely that it's creating a glare and I can't read it. Wow. P&W problems, right? We get so used to the gray that when it's sunny, we're like, wait, what is this? What is this gleaming orb in the sky that I don't recognize? I don't even know what that is. That's kind of where I'm at. Okay, there is our quadratic equation that John has given us, and he tells us, use the quadratic formula to determine the roots. Let me show you those words. It's just a fancy way of saying solve. The roots of an equation mean the values for x, all right? Use the quadratic formula to determine the roots of the equation, okay? He uses that same expression for the second example. Use the quadratic formula to determine the roots, but here he finds another way to say it. Use the quadratic formula to find the values of x that satisfy the equation. He's just saying solve it. So don't let that stress you out too much. The important thing is he's saying use the quadratic formula. If he wants us to complete the square, he'll say solve by completing the square. So he tells us what to do. Later, next year, you'll get to go off-road and do it however you want. Almost everyone chooses the formula. Okay, here's what we do. Remember how we said that the standard form looks like this? This is important because it helps us see what the values of each of the letters are. And that's the first step of this. Here's our steps 1. Identify A, B, and C. And the way that we do that is to make a little chart. I always make it, well, I almost always make it over here on the left side. A is equal to 3. B is equal to 2. C is equal to minus 7. Okay, so I'm going to write here, watch for minus signs. Okay, minus signs matter. We include them. Okay, second step is plug in to the quadratic formula. And I'm going to tell you a cute story. Use buckets. That's not the cute story. I once had a student named Isabel. She just graduated with her master's degree, so it's been a few years. But Isabel was an extremely dedicated, hard-working math student. It was an uphill battle for her. A big part of that was because she had health issues. So when she was in middle school, she missed almost like a full year of school because she had to have surgery on her back, and it was life-altering. So it was just one of those situations where she just missed a year and then she never really felt like she'd fully caught up. So Isabel worked hard and she did a good job, but she usually wasn't the first and the fastest to understand a new concept. She needed to spend a while with it. She took math with me, but she also took math in a more traditional classroom with a teacher called Nancy, and Nancy's a really good friend of mine. So that was a fun part about this story. And so Isabel was learning things with me and with Nancy kind of at the same time, right? Sometimes she'd learn it a day or two ahead in Nancy's class. Sometimes she'd learn it a day or two ahead in my class. This was back in the before times when we actually met in person. Quadratic formula she learned from me first, and she had heard me say and taken it to heart to always use buckets in this calculation. Now, just as a little side note, the reason why it's important to use buckets is when it's possible to have minus signs in our values, but we also have minus signs in our formula. That's when you know you need buckets, because if you're putting a negative value into a bucket that has a minus sign attached to it, it's easy to screw it up, okay? So Isabel had heard me say that. She took it to heart. She went to class with Nancy one day, and Nancy was teaching them how to do quadratic formula. Well, again, Nancy is a dear friend of mine. Our kids grew up together and we're friends together. I respect her, she respects me. But Nancy forgot to stress to her students to use buckets. And so she was doing a quadratic formula problem on the board, teaching it to the students, and she got the wrong answer. And she couldn't figure it out, and she was stymied. And of course, you know how that is when the teacher gets it wrong and you don't know what they're doing, right? You just sit there and wait for them to figure it out. So the class is doing that. But then, cautiously, almost timidly, Isabel raised her hand and said, "Nancy, I think you forgot to use buckets. And that's why you dropped one of the minus signs because you didn't use buckets. And that's the problem." And you can imagine, you know, again, Nancy's trying to figure this out and she's getting advice from a student who is not usually a student that is going to catch a teacher's mistakes. But this time, Isabel did. And Nancy was like, "Holy smokes, Isabel, you are right. That is exactly what I did wrong. High fives to you for catching my mistake." And it was a big, glorious moment because Isabel was in this class with a lot of her friends. And so she got this high praise from the teacher for catching a mistake in the flippin' quadratic formula, which, I mean, it's just a scary looking thing, isn't it? I'll tell you my nickname for it after I finish this story. But you can imagine how delighted Isabel was when she came back to meet with me the next time and said, oh my gosh, you will not believe what happened. And she told me that story. And it was just joyful because who doesn't love to correct the teacher, right? How fun is that? And especially when you're a student who feels like you have had to struggle to just keep up, to be able to catch a teacher's mistake and point it out to them when they can't find it themselves. Woo! It's a sweet moment, isn't it? So that's the story of Isabel and using buckets in the quadratic formula. Are you ready? What we're gonna do is we're gonna flip to the next page, and then I guess I'm gonna have to rewrite that. 3, 2 minus 7. And then we've got our quadratic formula right here. I'm not gonna rewrite it over again because I can just look at it right here. And we're gonna fill in the blanks. X equals, now this is what I do. I first write the quadratic formula, but instead of putting in the letters, I put in buckets. And this is what I want you to do. For every letter in here, I've put in a set of parentheses. That's what a bucket is, right? It's a set of parentheses. Spoilers. I like to call them buckets. It's more fun. All right, so this is how I start. What step am I on? Excuse me while I flip. 3. I know this isn't really a separate step, but I'm making it a separate step because I want to emphasize it. Work carefully. The biggest mistake students make in these types of problems are just silly little copying wrong, multiplying wrong. It's not, we're just doing some straightforward simplification, but man, it's easy to just make little mistakes. All right, so the question is, do I want to go in order of A, B, C, and put in the A's and then the B's and then the C's, or do I want to just work across and put in the letters as I come to them? Either way is perfectly fine. I'm going to go across. So I know a B, I'm following the letters and reading across. B is 2. I use B another time. Then I need A, which is 3. C is minus 7. Oh, there's where I'm thankful for the buckets. And then we use A once again on the bottom, okay? It doesn't matter whether you use that strategy. Sometimes I'll go down the list. I'll put in the A's, then I'll put in the B's, and then there's just one C at the end. It doesn't matter, just be careful. Now, we simplify. Obviously, we have a lot of simplifying to do in here. I will give you my, what works for me, and then you can experiment if you don't like that and find a different way that works for you. That doesn't hurt my feelings. What I do is I simplify within the pig house first. Two squared is 4. These two minus signs are going to make a plus. 4 times 3 times 7. Let's see, is there an easy way to do that? I know I don't want to do 28 times 3. I'm looking for a pattern I can do in my head. 12 times 7 I think I can do. That is 12 times 7 would be 14 and 70, so that would be 84. Four plus 84 is 88. Okay, now I'm going to, now that I've got the pig house simplified, x equals, now I can do everything, minus 2 plus or minus the square root of 88. I'm writing this outside of the pig house, but the values all come from inside the pig house, over 6. Okay, that looks really good. We're getting close to done. However, we want to simplify this if possible, and I can see that there are at least 2 pigs I can take out, because this is 8 times 11, and 8 is 2 times 2 times 2 times 11, which is prime. These are all prime now. So I can take out a pair of 2 pigs. 2 pigs in the house is 1 pig out of the house, and then I'll have these guys left inside. So x equals -2 plus or minus, this is the 2 pig that jumps out, and left inside I have 22, and the whole thing is over 6. Oh boy, it's looking even better. But John's giving us a primer in simplification. And here's my last instruction. Factor and simplify as much as possible. And so we see here, oh, we've got even numbers in all 3 terms, don't we? We can't cancel where we're at. Now we have to factor first, but let's factor a 2 out of these numerator terms. So if I take a 2 out, I'm left with -1 plus or minus. This doesn't affect the factoring at all. Square root of 22. I'm factoring the wolf, not the pigs. Over 6. Now I can cancel the 2 against the 6 because now I'm multiplying. Here my 2's were being added and subtracted. You can't cancel when that's happening. You have to factor them out. Now the 2 is being multiplied. And so my final answer is x equals -1 plus or minus square root of 22 over 3. This is the way John writes the answers. I personally would like it even more if they were split into 2 fractions. But either of these answers are correct. That is how we factor using the quadratic formula. Now I'm going to tell you another story. This is such a day for stories. When I, again, in the before times, I taught in a physical classroom. It wasn't a traditional class. There were only like 4 or 5 kids, and they were all like my daughters and their friends. But there was a boy named Zach who was in the class. Zach has a very creative mind. How old is he now? He's 30, 31. He's got a daughter and a wife, and he lives up near Mount Vernon, and he develops broccoli seeds for a vegetable company. I'm not kidding. That's so cool. The classroom where we met had a big whiteboard, and we met directly after lunch. So my students would often gather in the classroom and eat their lunch or just hang out there together for a while before class started. And one day I came in and they had been in there hanging out, and Zach had drawn this huge, really elaborate dragon on the whiteboard. And it was really cool. And as I came in, he was just completing a bubble mouth flame, like this kind of a thing, like a cartoon bubble coming out of the dragon's mouth. Like that was the part attached where the dragon's mouth was. And it was like he was going to write some speech bubble in here. Or he was breathing fire. And I said, what words would be coming out of the dragon's mouth when he breathes fire? And Zach got this devilish little twinkle in his eye, and he wrote x equals -b plus or minus square root of 4ac all over 2a. In Zach's mind, that is the fire, the fire-breathing dragon. That's what would be inside driving his fire, which we all thought was hilarious because this is like a fiery, devilish thing to say, isn't it? So from then on, we began calling the quadratic formula the man-eating dragon, because it is so fierce and formidable. So I very often refer to the quadratic formula as the man-eating dragon. Now you know. Okay, let's do another one. Ready? I know this lesson is it's going on and on and on, and it's probably mostly due to all my stories. But what can I say? Okay, use the quadratic formula to determine the roots of minus 6 equals minus x squared plus x. This is John trying to be cute, right? He scrambled this up and made a big mess, and now expects us to sort it out so that we can actually solve this problem. So I look at the x squared first and I go, okay, it's got a minus sign. I don't really want that minus sign. So let's swim everything this way so that that x will be positive. Remember that we can skip showing the steps if we remember the simple rule: when you change sides, you change signs. So if I want this to come over here, I can make it positive. Then I'm going to bring this over. That's going to become negative. This 6 is not changing sides, so it stays just the way it is. Okay, beautiful. Now we need to write our A and our B and our C. If they're in order, the proper order, it's an easy enough thing. A is 1, B is minus 1, and C is minus 6. Okay, we're off to the races. Now we're ready for our formula. I recommend when you're doing the homework, rewrite it every time so that you can memorize it. That's a great way to memorize things. But I'm just going to bring ours over. Again, we recreate it by using buckets in place of all the letters. A lot of students think, I don't need the buckets. Trust me, you're going to save yourself so much time in making mistakes if you just put the buckets in. It only takes a hot second. Okay, now we'll put them in this time. I'll go in order A, B, C. Last time I went in order as I came across them. Now I'll do A goes here and here. B goes here and here. And C just goes in one place down at the end. Beautiful. Okay, now we're ready to simplify within the pig house. Minus 1 quantity squared is minus 1 times minus 1. That's positive 1. These two minuses are going to give us a plus. 4, good, the 1 we can ignore, so this is 24. As I jot down the sum there, I go, wait a minute, wait a minute, wait a minute, wait a minute. 25 is a perfect square. So now when I go through again, I'm going to see, okay, this becomes positive 1 plus or minus square root of 25. That's just plain 5 over 2. That got real simple real fast, right? This, remember, came from being square root of 25. And I just didn't even bother to write that down, but I don't want to confuse you because this was the square root of 25, right? Now this we can actually solve. X equals 1 plus 5 over 2, or x equals 1 minus 5 over 2. Normally we leave that plus or minus in there because we can't really go any farther, but this time we can. This equals 6 over 2, so we're saying x equals 3. And this is minus 4 over 2. So this it would be minus 2. I'm just simplifying these fractions. And we go, wait a minute. These answers are so simple, they're integers. Could we have solved this by inspection? And so let's go back up to the top here. Here, let me cover this up so you don't get distracted. If we go up to the top here, we think, wait a minute, could we have just done this? What are two numbers that multiply to negative 6 and add to negative 1? Oh yeah, negative 3 and positive 2, right? And we would set those equal to 0. Here, I'll put it this way. And then we would say x minus 3 equals 0, or x plus 2 equals 0. And then that would lead us to our answers of x equals positive 3 and minus 2. The N kind of got lost there. So what we see is that we used the man-eating dragon to solve a quadratic equation that could have been solved by inspection. What that proves to us is that we can use the man-eating dragon at all times, and we will always get the right answers. Sometimes, like in our last problem, I don't know about you, but I don't think that I ever could have calculated with by looking at it that this was the pair of numbers that would make that equation come true. I couldn't have seen that. This one I could have seen. I didn't. We did what John said. John said to complete it using the quadratic formula. So we had no options there, but we see, oh, it works, even if a simpler version would have worked. Okay, let's do one more. Use the quadratic formula to find the values of x that satisfy the equation. And once again, John's being cute and clever. Okay, our first step is to get it into standard form. I see that minus sign, I don't like it, so let's bring this across. We'll make it positive. This is already here. And then this 7 will bring across and we have to make it negative. Okay, now we go, oh, we're not gonna fall for this trick again. What multiplies to 7 and adds to minus 1? Well, nothing, because only 7 and 1 multiply to 7, and there's no way that's gonna add to a minus 1. So, fine, John, we're not gonna catch him in this one. So we set up our A, B, and C values. A is 1, B is minus 1, C is minus 7. We grab our man-eater. Here he is. Set up our buckets again. Right, there it is. And then we'll use this to fill in the blanks. This time I'm gonna go in order again of how we find them. So B is minus 1, A is 1. I like to do both A's at the same time, and then C is minus 7. Okay, so we fill them in carefully, trying not to make any ridiculous mistakes. Now we are ready to simplify. I start by doing the pig house. Minus 1 quantity squared is positive 1. These two go together to make plus. 4 and 7 are 28. They add to 29. Okay, 29 is not a perfect square. 29 is prime, so we can't even break that down, which is kind of a relief. That means we don't have a bunch of simplifying to do. So now we can write x equals, these two negatives make a positive, plus or minus the square root of 29. Remember, just because I write it on top doesn't mean it's outside of the pig house. I'm just simplifying what's in the pig house right there. Over 2 times 1 is 2. And in this case, that's our final answer. Yay! That's lesson 119. That's using the quadratic formula. I've introduced you to the man-eating dragon. We've derived him, and we figured out, more importantly, how to solve him. Now, this is a great example. Yeah, this problem has some tough simplifications, but this is a whole lot easier than completing the square, isn't it? It's far fewer steps. So, the man-eater does his job. He gets us to our answer with a lot less fuss and drama. You have to memorize him, and you have to be patient with some of these solving and factoring steps, but he gets the job done faster. And we will spend a lot more time with him next year, so if he makes you a little nervous, don't worry. He'll become your friend, and you'll be friends with a man-eating dragon. How exciting is that? All right, I will see you tomorrow, and look what we're gonna do tomorrow. We're gonna check our final box. Woohoo! And the last lesson, I'll just warn you, is relatively unimportant. 119 is the big, crashing, exciting end of Algebra 1, and then we'll do one more lesson just to get to an even number. Okay, thank you, bye.